welcome to Thursday's edition of Cracking the Cryptic, where we might have something really incredible for you today. This puzzle has been recommended about a dozen times to us just over the last 2 or 3 days. It's called Twixt, and it's by Tall Cat. And I've just gone to the Logic Masters Germany page where it was published. And some of the comments on it are from really the luminaries of the Sudoku world. Look at this. We've got comments from Jovial, Fistamafel, Udakos, Mr. Menace, all basically saying this is a great puzzle. And it only has 3 stars out of 5 for difficulty, so it might even be approachable. The sort of holy grail of Sudokus. We shall see. I'll read you the rules in just a moment. The first thing I want to do, though, is to give a shout out to somebody called David Reynolds. Now, David wrote us an email yesterday saying that he follows the channel and he is blind. And I mean, this is just, it's mind-bending. Apparently, David has a Braille Sudoku board and he sets up the puzzles on that board and then sort of fills in the numbers as they occur to him, as he sort of mentally processes the puzzle in his mind. Isn't this just incredible? He has learned X-Wing techniques from following the channel. It's blown both Mark and my mind. So David, we're delighted to have you following us, and yeah, we will. Well, anyway, you know, it's just extraordinary. Now, the next thing I want to mention is tonight, 10 o'clock UK time, so about an hour and a half after this video appears, hopefully, if I can solve the puzzle, I'm going to be live streaming the next edition of the Witness playthrough. So this is me trying to find my way through this incredible game. I think the game isn't new at all. I think it was released in about 2016, so it's 5 years old. But for me, it's just breathtaking. It really is. So my voyage of discovery will continue tonight, and you'd be most welcome to join me. And so I don't know how you set reminders for these things, but anyway, 10 o'clock tonight, come to the channel, and hopefully I'll be there playing away. Now, what else have we got to say? Oh, just one other thing. If you're a patron of the channel, it's not too long until the 1st of September, and the 1st of September means Patreon reward time, and we've been working on a Looney Tunes themed set of puzzles for you, which are looking very cool indeed. So yeah, look out for those. They are not long away. With all that said, let's get to this. What are the rules? Here we go. Normal Sudoku rules apply. Digits along each arrow must sum to the digit in that arrow's circled cell. So we've got normal arrow rules. So let's look at this arrow here just to explain what this means. So if we put 1, 3 and 5 on this arrow, what we put in that arrow's circle is the sum of 1, 3 and 5. So 1 plus 3 plus 5 is 9. We put 9 in there and we'd be good to go. That is how arrows work. Cells along lines between 2 filled circles must have values between those in the circles. So this is our old friend Between Lines, which I did that monstrously, well, it was a brilliant but difficult puzzle the other day by Zetamath, which was all between lines apart from a single arrow. Well, this one's got between lines in it as well. So let's just think about these 2 cells then. What we're told is that whatever we put into these 2 cells, or, well, let's put some numbers on the line first. Let's put 4, 6 and 7 on the line. So we've got 4, 6, 7 on the line. That means these 2 cells must bound the numbers 4, 6 and 7. So we could, the sort of minimum number we could have would be 3, or the maximum minimum number, if you see what I mean. And we could have 8. But we could also have 1 and 9. We just have to make sure that the numbers along the line are surrounded on both sides. So there's sort of the minimum of these digits is 4, therefore we need a number that's 1, 2 and 3 in one of the circles, and the maximum number on the line is 7, therefore we need an 8 or a 9 in the other circle. So I've explained that particularly ineptly, but hopefully it's fairly clear what's going on. Now, do have a go. The way to play is to click the link under the video. Now I get to play. Let's get cracking. And the first thing I'm tempted to do is to... I've been trying... I do this every time, and it never actually leads to anything nowadays. But let's have a look at the the circles with the 3 cell arrows leading off them. Because we know that a 3 cell arrow, where those arrow cells are all in the same box of the Sudoku, so they have to be different digits, the minimum I could make these 3 digits is a 1, a 2 and a 3. So that means 1 plus 2 plus 3 is 6. I've got to put at least 6 into the 2 circled cells, which are 6, 7, 8 or 9. Now, does that mean anything to us? No. No, it doesn't. It doesn't seem to mean anything to us. Right, I'm going to do something else then, because I can see that there's some geometry that's interesting about these between lines as well. So let's think about this square. So whatever this square is, let's say it's 6, just for the sake of exposition. If it's a 6, where do you put 6 in box 6 now? Well, not in those squares by Sudoku, not on the between line, because if we were to put 6 on the between line, that would not make sense at all, because the circles are meant to bound the digits that appear on the between line, not be the same as. So we can't put 6 in any of those cells. So whatever goes in this circle must appear in one of those 3 cells. And therefore, I suppose it must appear on the arrow at the top. So, yeah, so basically maybe we colour this in. So that cell there must appear in one of those 3 cells and on one of those 3 cells. And the same obviously is true the other way round. So this cell can't be there or there. So that's also in one of those 3 cells, and therefore in one of these 3 cells by Sudoku. And the same must be true on the other side of the grid. Look, so we've got a symmetrical between line pattern. So we're going to get some colouring over here. I'll use orange for this one, because I'm going to have to overlap the blue, and I believe that's the best for colour blindness. So what does all this mean? So now we know that we know that blue and orange are at least 3 apart. So if this was 1 and this was 5, 5 would transpose down onto the arrow there. 1 would transpose into one of those 3 cells there. No, actually, maybe this isn't right either. I feel like there's something here. I mean, this pattern looks so like it looks very, very deliberate, doesn't it? And this would seem to be the obvious corollary of thinking about this pattern. But I'm not seeing anything. Okay, we're going to resort, I think, to the classic between line trick, which is looking at 1s and 9s then. Because what you can never do on a between line, if you try and put 1 on the between line, what digit are you going to put that's beneath 1 in these circles? Well, you're going to have trouble. You can put 0 in the software, but you can't put 0 in Sudoku. So you can't put 1s or 9s on between lines. So that means there's a whole load of cells in this puzzle that do not have 1s and 9s on them. Now, okay, right, there I have at least something I have found. Yeah, okay, it doesn't work for 1s this, but it works for 9s. I'm going to look at 9s in column 2 and column 8. Because if we take a look at this, you can never put a 9 on a 2-cell arrow, because then the circle will have to be 10 at least. So the 9s are not there, the 9s are not on the purple lines, which are between lines, and they're not there. So the 9 in column 2 is in exactly one of those 2 positions. And it's exactly the same, because of the symmetry, in column 8. So the 9 isn't there, it's not there, and it's not there. So we actually have an X-wing on 9s. What do I mean by an X-wing? Well, it means the 9s in the finished grid will either be exactly here and here, or exactly here and here. And we know that because the 9 can only occupy 2 places in column 2 and 2 places in column 8. And what that means is it has an effect on the row, of course, because that means that in this row one of those two is definitely a 9, and in this row, one of these two is definitely a 9. So now we can't put 9s in any of the between line circles in column 1 and column 9. And that, so is that affecting 8 then? So now, if you can't put 9s in these circles, you can't put 8 on the between lines, because if you do, you'll need a 9 in the circle to bound it. Wow, okay, right, this is genuinely interesting now, because now in column 8, where do I put 8? You can't put 8 on the between line because you can't put 9 in the circle, and you can't put 8 on a 3-cell arrow because you'll definitely get to at least a double-digit number in the circle. So in this column, that is an 8-9 pair. It's not 6, 7, 8, and 9. We know there's a 9 in one of them, and we now know there's an 8 in one of them as well. Now, in this column, we can't put 8 on the between line because we can't put 9 in the circle. But we can put 8 on the arrow because it's only a 2-cell arrow. So maybe that's not quite enough for us. If we had 8s, if we had an 8-9 X-wing, we had an 8 and a 9, would that be a problem for some reason that I'm not immediately seeing? That would rule 8 out of these cells as well, which would mean we couldn't put 7 on the line. Oh, right, okay. No, that's not possible. That's not possible. That's really interesting. In column 2, I was wondering where 8 went because it's not on the between line. Now, if 8 is in the circle, I think the puzzle breaks, because now there's literally nowhere to put a 7 in column 8. And the reason for that is that I can't hide a 7 on the between line, because if I do, I need to put 8 or 9 in a circle where they can't go because of the double X-wings we've got on 8s and 9s. And I can't put 7 on a 3-cell arrow because I'm still going to get up to 10 by the time I've added 2 more digits to it. So there's no 8s in those cells, which is interesting. So that means that... Oh, that's weird. Right, okay. So that means one of these arrows has an 8 on it, and therefore it will add up to 9 because there's no other higher number available. So one of these two dominoes is a 1-8 pair, and it goes with the 9, wherever the 9 lives. So one of these strings of digits is a 1-8-9 triple, but we don't know which one. This is really, really cool, isn't it? It's very interesting. 1-8-9, I've got to remember that. So one of these is 1-8-9. And in this column... Oh, right. Let's come back to the question of 7s. So, I can't put... Oh, hang on, No, I haven't broken it. I see I can put 8 in... Oh, good grief, right. I was about to say I've broken the puzzle, but I don't think I have. So I was worrying about where 7 went in this column, because 7 definitely cannot go on an arrow. So 7 is on the line. But that's okay. We can put 7 on the line because I can put 8 in a circle. I can't put 9 in one of these circles because of the X-wing, but I can put 8 in it. So now I've got an 8 X-wing. Oh, good grief, this is madness. What the... So now 8 can't go in these cells. Oh, okay, well that's... Oh, I see. So this is perhaps a more elegant way of deducing what I just deduced. So yes, the question I could have asked after the 8-9 pair here is where does 7 go in the column? Once I figure out 7 goes here, I work out 8 goes here. Now look, the disposition of 8s in the finished grid is going to be an X-wing. The 8s are either in those 2 squares or those 2 squares, i.e. none of these cells can now be an 8. Now I can't put 8 in either of those 2 cells, so we now know 8 in this column is shifted onto an arrow, and that gets me my 189 triple, which I got sort of by a different route. But I also can't put 8 in those cells or 9. So I can't put 8 or 9 in those squares. So I can't put 7 on the between line. So 7 has to be in a circle. Wow, wow, wow. Oh, this is just ridiculously clever. This is some sort of masterpiece. Right, and it's also intricate. Let us think about this. So 8s can't go there and 9s can't go there. So the question I'm asking is, where does 7 go now in column 2? Because if we can't put 8 or 9 in a circle, I cannot put 7 on this between line, because it needs to have a higher boundary, and the 8 and the 9 are not available. So where are we going to put 7? It's got to be in one of these 6 cells. Now we might, at first blush, think, oh, I can put 7 on an arrow. Well, normally you could, but not when one of these strings of digits is a 189 triple. Because what higher digit am I going to add up my 7 to? I can't add it up to 8, because 8 is in one of those cells, adding up to 9, and I can't add it up to 9 because the 8 is being used to add up to 9. So 7 cannot go on an arrow. And if 7 can't go on an arrow, it must go in a circle. So that is a 7-9 pair. That is a 7-9 pair, and one side of it has a... Actually, yeah, I'm going to notate that now. One side of it has a 1-8 pair on it. Now, does that mean... Can I use that somehow back over this side again? So if we know we've got 7s in one of these 2 cells... what does that mean? 7. I know there's a 7 in one of these. I know one of these is a high digit, so I know the other one is a low digit. I see. So I'm not actually learning very much more about 7s over here, I don't think. And I can still put 6s on the line. And I suppose I can still put 6 on a 3-cell arrow, because 6 plus 1 plus 2 does equal 9. Ah, okay. I might be running out of room with this, or it might be running out of legs. On this side, I've got to put 7 in one of these. But I could still... I think I can still have 6 on the between line, because I could have a 7 in one of those and create an X-wing that wouldn't break this over here. Ah, no, well, yes. In fact, yes. Okay, let's go further. One of these arrows is a 1-8 pair. So where does 6 go in column 2? Is it possible that the other arrow contains a 6? Well, no, it's not, because if it contains a 6, we know it's adding up to 7, because 1 and 8 are adding up to 9. So if there's a 6 on an arrow, in order to add it to 7, you'd need a second 1 in the column, which is impossible. So where does 6 go in the column? It goes on the between line. And if 6 goes on the between line, what do we put in one of those 2 squares to bound it, given that we can't have 8s because of this 8 X-wing, we can't have 9s because of that 9 X-wing? Well, it's going to have to be a 7 in one of those 2 squares. And if there's a 7 in one of these 2 squares, I've now got a 7 X-wing pointing back over here. This is just mind-blowing. Sevens. 7 X-wing pointing back over here. So that... Yeah, I think I even thought about this a moment ago and didn't see how such a 7 X-wing would actually do much more for me, because I need a low digit to accompany my 8s. Good grief. Okay. Okay, so what on earth does this mean? The answer is I don't know yet, but I'm enjoying trying to find out what this puzzle is all about. We've got 7s, 8s and 9s all in X-wing shapes. I suppose if, well, one of these is a 7, which means its between line could have a maximum on it now of 6, 5, 4. That means these squares here have only limited options. The low digit is a 1, 2 or a 3, and the high digit is a 7. And we know that, so one of these is a 7. Ah, no, right. Right, okay, well I think I now know what those 2 digits are because of my colouring at last. I think that has now paid off, hasn't it? Yes. Yes, it has. Right, this has to be 1 and 7. Because, let me show you why. Let's just try 7 and 2. If we go 7 and 2, you can see this 2 gets transposed here, and it goes into one of those 3 squares, where it must go on the arrow. But this is a problem, because the moment this is 7, this is 9. And we know that 9 needs to go with 1 and 8 on its arrow. So it can't go with 2. In fact, you can see here it can't go with 2, because the 7, you'll need a 2 and a 7 to add up to 9. So you just can't do this because of the geometry. If you try 3 instead, you're just going to move a 3 onto the line where we know this is going to be a 9 and it's going to be a 1-8 arrow. So the way it sort of unwinds is broken. And what that means is the only digit you're going to be able to accompany the 7 with in these 2 squares is the 1. And why does this work? Well, of course it works now, because let's do it the other way around. If that's the 7 and that's the 1 and this is the 9, now this 1 gets transposed down here, which is exactly where it should go, because we know there's an 8 in an arrow adding up to 9. So this can now be a 1-8 pair. So that means that we can get rid of those corner pencil marks, I think, and we've now got a 1 in one of these squares. It doesn't actually do. I don't actually think that's done anything really. I mean, it's got rid of a couple of options, but I don't think it's. I still haven't got a digit, of course. Digits don't live here anymore. Oh dear. Now, what else do we know about the world here? We know we've got a 9-1-8 arrow on one side of the grid, and a 7, either a 2-5 or a 3-4 on the other side. So these 3 digits are made up of 6, and then whichever version of 7 is not used on the arrows in column 2. But the problem is, when your lower boundary is a 1, that has a lot of flexibility. On this side of the grid, we've definitely got an 8 on an arrow, so we've definitely got a 1 on one of these arrows. Oh, which side of the grid is the 9 on? Oh, hang on a minute. If that's... which side of the grid? yeah, the 9 flicks round with the X. Oh, this is just gorgeous. Right, I've now understood. I've understood something else. Right, remember what we said about 9s. 9s are on one of these diagonals. Either both of those cells as a 9, that's one possibility, or both of these cells is a 9, that's the other possibility. One of those things is true. So the moment I make one of these two squares an 8, I fix the orientation of my 9 X-wing. Ordinarily, this might be something that we just gloss over and notice and just take note of and don't really care about. But here it's enormously powerful because I know that whichever one of these is an 8, it has a 1 on its arrow. So let's go through this. If this is 8, we now know the orientation of the X-wing. We now know that this is a 1-8 pair, and we know that this has a 1 on its arrow. And now where are we going to put a 1 in row 3 of the grid? I've got to put it somewhere. And we might think, well, I can put it here. Nope, that's a between line. That will not work because I've now got to put 0 or minus something into one of those circles. So you can't align the 1s in the top of the grid at all. It just won't work. But look what Toolcat has done here. If we put the 8 here instead and get the 9s in those two squares, it will work because I'll show you why. Now we've got a 1 on this arrow here. We've definitely got a 1-8 pair here. And now we have to put a 1 in one of those 3 squares. But this between line has a different geometry to this one, and it leaves a space. So that's got to be a 1. And that's the only configuration that will work. It's just beautiful. It's absolutely beautiful. Now we know that that arrow is a 1-8 pair. We now know this is a 7. We therefore unwind the 7's X-wing and we get all this. We can delete those at the top of column 2. This is absolutely stunning. How this is only rated 3 stars out of 5 though. This is not easy, is it? Is it? Hang on a minute. Now what else have we got? Now we've got the 8 X-wing I can unwind. So those two come out. So now what have we got? This digit here, which I now know is... So I now know this is a lowish digit. So 8, 7, 6, 5. This is a 2, 3 or a 4. It can't be a 1. Which almost fixes this, but doesn't quite. Almost got a quintuple as well in this box, because obviously the only digits we can put on 3-cell 8 arrow are 1, 2s, 3s, 4s and 5s. Right, okay. What about that between line then? Yes, this is fixed. Right, this is lovely as well. So now look at this, these two cells here. And let's just ask from a Sudoku perspective, what are the possibilities? Now I think both of them see 1, 7, 8 and 9. That one does. It sees it in its box. This one does in its row. So the options for these squares are 2, 3, 4, 5 and 6. But there are 3 cells between these two digits. So actually I've got to space them apart the maximum I can in order to allow this line to be filled. So those two squares are going to have to be 2 and 6, and this line has to now be 3, 4 and 5. There's only just enough room for it to work. Now this square can't be 2 or 6 because, yeah, this is so clever. This is so clever. Right, look at this square now. So now we've got these as 2 and 6 and we know they're different digits. This cell sees both of those digits. What do I mean by sees? Well, it sees this, whatever that square is, it obviously rules itself out of this cell because it's in the same row. And whatever this cell is, it rules itself out of here because it's in the same column. So row 7, column 3 cannot be a 2 or a 6. Therefore, it has to be a 3, 4 or a 5. And that creates a 3, 4, 5 triple in the row, which means that square can't be a 3 or a 4, and that square is a 2, and now that square is a 6, and that square is a 2. This is one of the most brilliant puzzles I have ever seen. It is just, it's absolutely superb. Ah, and the 8 arrow now can't be 1, 2, 5, so that's 1, 3, 4. And what now? Ah, we've got something going on maybe on this between line, have we? Or maybe this arrow as well. Let's look at this between line. If this goes upwards, it would have to be a 7 and an 8 on the line, and then this would be a 9. If it goes downwards, 5, 4, this has to be a 2 or a 3. So this can only be 2, 3, or 9. Okay, maybe that's not that good. Yeah, because we can't even use that to get the value of this one. We don't know whether this is a high or a low digit. Yeah, okay, well let's have a look at this arrow. Because this arrow here now can't have 1, 3, 4 or 5 on it. Oh, so it's got a 2 on it. It must have a 2 on it, and that 2's got to go there. Why do I think it's got a 2 on it? Well, let's imagine it didn't have a 2 on it. These two digits, therefore, would have a minimum value of 6 plus 7, which is 13. We can't put 13 in this square. It would be most unlucky for us. So there must be a 2 on it. That must go there by Sudoku. That gets rid of the 2 from that one. And this is nearly forced now. This has to be 6 or 7. That has to be 8. Whoops. 6 or 7. That has to be 8 or 9. Oh, okay, that's not actually done very much at all. 2, 3, 4, 5. What do I do next? I must ask. I don't know. I don't know what to do now. I've got one in it. I've got one must be in one of those 3 squares because of our colouring logic. 7 must also be in one of these squares by our colouring logic. So maybe it's colouring logic on one side of the grid. 8, 8, yeah, there's an 8 in one of those. And a 2 in one of those. And a 2 on the 9 arrow. Actually would be very useful if I knew there was no 1 on the 9 arrow. Can't put 1 on the between line. No. Okay, I'm not sure if I can do that or not. I can't see how to do that. 2. Beautiful. Beautiful. Now look at row 3. This 2 here, there's no 2 in that square. This 2 here, there's no 2 in that square, so there's got to be a 2 on the between line, and that's huge, because now if there's a 2 on a between line, one of the digits that's in the circles bounding the line has to be a 1, and it's not that one. So this is now a 1. That's no longer a 1. That's no longer a 1. 1 is now locked up. Beautiful. 1 is now locked off my 9 arrow. That's become 2, 3, 4. This is a 2-8 pair now. Oh no, now we even know this cell, because there are 3 digits between the 1 and this digit. So if that's a 3, I could only put 2 in every single one of those cells. So that's a 9. Which might be useful. Or not. Well, it's the least useful in terms of sort of pincering these digits, but is it doing something somewhere else? The answer seems to be no. Oh, look at column. Look at this column. This 1, 3, 4 and this 2, 3, 4 join together and form a quadruple. So those squares have got to be 5, 6, and 7 now, down the centre of the column. So these squares have got to be 3, 4, and 9 to complete the box. Where does 9 go in box 9? It can only go there. That's nice. That gets me an 8 here. that means this square becomes a 6. This 8 gives me the 8 and the 1. Aha, and that's a 1 now, so this is a 3 or a 4. 1, 3, 4. Those two squares have got to be, I think, a 5, 7 pair to complete box 9, which means we should be able to get those two digits. They are a 1, 6 pair, I think. And now these two squares have got to be also a 5, 7 pair. So actually we've fixed quite a lot of the options in columns 7, 8 and 9. We've got, oh okay, and I've got to place a 7 in row 8, and it can't go there. It doesn't seem to be able to go in those two squares, so it must go there, so that's another digit in. 7 and 5 go in. These two squares, look, are forced to be 7, oh, they're also 7 and 9, but they're not resolved. So these two squares are 3s, 4s and 6s. And that square is a 3, 4 or a 5. Which, might be interesting, but might not. Okay, so what do we do next is the question. And everything in this puzzle so far has been incredibly linear. It's been tied together with the utmost care. Oh, I know what it is. 6 and 9. So those two have got to be 7s and 8s, and there's an 8 there. So that's an 8, that's a 7. That's no longer a 7. That's no longer a 7. This 8 is giving me an 8 here, so that's a 2. 8, 8. Can I put an 8 on this arrow? If that's an 8, that's a 9, and this would have to be a 1, which it can't be. No, so 8, 8. 8's not possible here. 8's not possible here by Sudoku. 8 goes there. So 8 is in one of two places in box 1. Okay, now what do we do? 9 is not in this cell. 5, 6, 7. 1 is a little bit pinched in the central box. It's got to be in one of two positions. 2. No. Actually got very few clues left to use as well, so we're going to have to really make the clues that we have got sweat, I think. Oh, this 7 is giving me a digit over here, so that's a 7. That's a 5. 7's much. So 7 is in this domino in box 2. Come on, Simon, let's finish this off. How do we finish this puzzle off? Maybe this arrow is where we look now. Because I've just noticed that each of these cells on the arrow can't be 1 or 2. This cell sees a 1 beneath it and a 2 on its right, and this cell sees a 2 beneath it and a 1 on its right. So the minimum value of these squares would be 3 plus 4, which means this is at least a 7. Well, it can't be a 7, it can't be an 8, so it must be a 9. That's lovely. And that means I get 9 over in box 6 by Sudoku. 9. I've got an 8, 9 pair in box 1 now. And this arrow must be restricted, mustn't it? Because I can't use 1s and 2s to make the total of 9, so it's either a 4, 5 pair, which might be possible in either direction, or it's a 3, 6 pair. Now I've got a pencil mark. Oh, the pencil mark 6 is from the between line, isn't it? It was where do you put a 6 in the column, so that is good. So this could be a 6, absolutely. So that can be a 6, and that would be a 3. But this can't be a 6. So this, we've almost got something interesting there. Look, we've got 3s, 4s, 5s. Yes, I see how to do this. Look at row 3. These 4 digits we've got left to place can only be selected from 3. Well, this square is absolutely beautiful. this square sees 2 on the between line. So this square is 3, 4, 5, or 6. It's not 5. And that is what I needed. Look, I've now got a quadruple in this column, which means these squares have to be a 1, 7 pair, and there's a 7 here. So that's a 7, that's a 1, that's a 1. Can't put 1 on a between line, so one of those is a 1. This has to be a 7 by Sudoku. Now I've got a 5, 6 pair over here. And okay. Now, in fact, I probably could have done this earlier. But look, there's a 2 here. So where do you put 2 in box 4? And the answer is I don't really know. But it is important. It's in one of those 2 squares. Now my 7 arrow is suddenly fixed. It's not 1, 6. It's not 2, 5. So that's a 3, 4 arrow. So that's a 6 now. Whoa, sorry, messing up my pencil marking. That's a 6, so that's not a 6 down there. So we've now got, oh, I see. So that's a 6 in box 7. It's the only place you can put a 6 now. These 3 squares are now forced, aren't they? They have to be the other digits. So they are 2, 5, and 6. And we know that's not a 2. So this square here now can't be a 5 anymore. Oh, okay, look at this. So now I've got a 3, 4 pair in column 3. So this is a 5, which means this is a 5. Which means that's not a 5. 2, 5, 6. This is also, there's got 3, 4 pairs in column 1 now. So that means up here we need 2 and 5, I think. So we've got all sorts of pairs being generated. Oh, we've got a 3, 4 pair, a 5, 6 pair. Ah, there's stuff everywhere now. So that's got to be a 3, 4 pair, I think, in row 5. I've got a 3, 4 pair already in row 4. So these squares have to be 2, 5, or 6, and that's not 6. Okay, and these three squares we know are 2, 3, and 4. Look, that's not a 2. I've now got a 3, 4 pair in column 4. So so this is a naked single all of a sudden. This has to be 6, 7, or 8 from the column logic, and it sees 7, 8 in the row. So that's a 6, that's a 6, that's a 5. That's now a 2, which means this is a 5, this is a 6. This is now our old friend, the 3, 4 pair. And this square's not a 6 anymore. 2, 5, 3. I've got 3, 4 pair in column 5 now, so that fixes that square's a 2. I've now got a 3, 4 pair in column 6. So there are 3, 4 pairs everywhere. This 2 fixes the 2 and the 5 back in box 5 again. So this 7 is giving me a 7, 9 at the bottom of the grid. So 7 is forced to be there in box 2. That is a 1, 9 pair in box 2. These 2 squares are also forced to be a 5, 6 pair. Look, just to complete column 6. Got the what looks. Ooh, I hope that isn't a deadly pattern I'm about to get here. Ah, no, I can see something going on in row 1. I've got a 3, 4 pair. So that square's a 2. Which means that square's a 2, and that square's a 5, and that square's a 5, and that square's a 6, and that square's a 6, and that square's a 1, and that's a 1, and that's a 9, that's a 9, and that's an 8. Yes, okay, that was quite useful. Oh, so now I've got 3s and 4s everywhere. How do these get resolved? Ah, 9 arrow. The 9 arrow is going to be our saviour. Look, 9, we've got 5 plus something equals 9, so that's a 4, and hopefully that's going to go round the grid, maybe. Looks good actually. 4, 3. Oh, yes, it goes back to the top up there, which gets those 2 done. The 4, oh, I see, the 4, 3 comes in there. That gets me the 4, 3. This is just, it's ridiculously clever. There you go. There we go. Yes, that is just brilliant. well, there are other adjectives we could use, but just brilliant seems it's an apt description. That is just... I'm a bit blown away by that. It's just stunning logic from start to finish. The start of it is ridiculous. The fact that 9 is an X-wing here, and you can use that to eliminate 9 from a between line, which forces you not to have 8 on the between line, which then forces 8 to be an 8-9 pair here. I mean, it's so clear once you see it. And then you sort of get sequential X-wings. You get 9 X-wings, 8 X-wings, 7 X-wings. And the other, I can't really remember what I did then. I think I was able to get... Didn't I get a 6 on this somehow? But the other bit of it I really remember was this. This was absolutely lovely. Those two squares had to be a 2-6 pair, and they stopped this square being a 2-6. It's just gorgeous to me. It really is. And it's another beautiful, beautiful puzzle from these wonderful people who create the puzzles that we get to solve every day. We are so lucky. Let me know in the comments if you got through the puzzle. Let me know if you enjoyed it. I'm sure you did. I do enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic and a live stream of The Witness. See you then, hopefully.